Matplotlib overview and installation. So one thing you have to do is that, as I had mentioned, first thing first, you have to import NumPy. NumPy is the basic foundation. On top of it, all your SciPy, Matplotlib, everything's are built. So NumPy first you have to import, and then you have to import you have to import Matplotlib. Now, if you're not using Anaconda or Jupyter Notebook, you just have plain Python, then you have to use pip install Matplotlib. But you do not need to do that in Anaconda Jupyter environment. It's already there. However, you have to do this line what I was telling you about. From Matplotlib, import pyplot, and usually, pyplot, we like NumPy, as you have seen for NumPy, the alias was NP. So you are writing like import NumPy as NP. So just like that, here also the alias is PLT. It's a common universal, everyone uses this alias. So we will have to do from Matplotlib import pyplot as PLT. So which is used, and pyplot is used to do plot your 2D data. So this command is very, very important. But before you go that, you have to import NumPy. So first would be your import NumPy as NP. Second line would be from Matplotlib import pyplot as PLT. These two lines will be must. After that, if you want to plot just a simple line, you can have this whatever you want to do, plt.plot this, and then this line is also important. What is this line is going to show is that if you do not have this plt.show, your graph or the chart that you have made, it will not be visible. So your last thing you have to do plt.show that, and then bracket, that means that this is your inbuilt function. This is going to show you whatever chart that you have done over here. That's very important. Now let's move to our Jupyter Notebook and see, So the first thing that we are going to do is a line plot. So you guys remember the line plot. That's a very basic, like, it just shows a line, and, it could be multiple, it could be your X and Y, or, whatever two values at the same time, you can show it. So this would be your import matplotlib.pyplot as PLT. Then you have to do your cells figure. Your cells figure would be your whatever cells is there. Then you have your TV and then radio, or whatever the numbers you are providing on this. And then it would be your plt.plot. And then you give the name, whatever you want to do, TV, cells, and then you do plt.show. So that is, very bare bone structure that you are doing over here. That you are doing over here. So you can see that this does not have any, so you see your X level is showing 0, 20, 40, 60, 80. So the X level and Y level, your X would be your TV. So, your here, the first is your X, and then second one is your Y. But you see here, I haven't got any title over here. I haven't also got your X level or Y level. So how do I assign those level names? So it's very easy in Python. You have to just do plt.xlevel, and then, within bracket, you give whatever name you want to do. So here I'm just giving it as a TV, and then plt.y level is your cells. So what these are talking about is the information about the total cells. So what this is basically talking about is the total cells of a product and the advertisement medium. So, a particular product, it could be any product, advertisement had been shown over TV and radio. So it's showing TV means how much they have invested for advertisement in TV, and how much they have invested in advertisement in radio. and due to this, what has been the sales figure. So that's what they are representing over here. So it's basically so it's a TV, or you can also give any name over here, TV advertisement, and then Y level sales in dollar, and then overall you have to give a overall title. So how you are going to give the title? You can give the title as PLT dot title, and title could be whatever the chart is there, advertisement effect on sales. I just give any. You can do any name over there. That would be your PLT dot title. And then finally you have to show the graph. So that would be your PLT dot show. That would be your PLT dot show. Okay. So that's how you can add a legend. You can add how you can add your X level, Y level. You can add that title, and then you can show this graph. Now you see this graph has came in blue color because we have not specified anything, but you can very much change the color. You have the total control over many things. You have the total control over what could be this type of thing, which color you are going to use. So for these you can have R would be red, blue, green, whatever color you want to do. You can mention these things and the color line graph will change. And also you can have these type of things like whether it's gonna be marker code, plus sign, dot, all these things you have to do that. Also, you can also do marker if you use marker, so it will not be then you can also provide line style code, whether you want a solid line, dash line, dotted line, all these kind of things that you're going to do, you're going to have it. So here now we are doing it here. Here you see I'm changing it. So here plt.plot TV, cells, and then I am asking it the marker would be O, and then line style is this, color would be R, and give it a level as a TV. So you can change the color, marker, line style, everything. So here we are changing this thing. So here we are asking plot TV and cells, marker would be like O, so this is this one. Line style, give it a line style like this. Whatever the line style, that dotted line would be here. Color, R will stand for R would stand for your red, and then level, give it a level, say it like TV, and then that is this plot is there, and then plt dot plot radio cells, marker is this, line style is this, level radio. So these are the levels that should be there. And then I'm asking it to provide it with an X level and Y level. So this would be your plt.x level. Give any name, whatever name that you want to add on this on the X axis. So this would be your advertisement medium. That is your plt.x level. You're doing that. The same way you want to have some level on the Y axis as well, and that would be given by plt.y level. So, plt.y level would be your cells. That's what it is there. And then after that, you have to give an overall title to the graph. So that would be your plt.title. That would be your advertisement effect on cells, or whatever name that you want to do. And then you can do plt.legend, and here, the location you can just give lower right, or you can go to your Matplotlib documentation and see whatever the documentation location it accepts. So this is all the things that you can do. And plt.show is the final thing. Without this plt.show, this graph will not be visible. So plt.show, then this graph would be visible over here. So here you see that we have changed almost everything. We have changed what would be the color, what would be the marker, what would be the line style, etc. We have changed everything, but we haven't changed one thing, that is the line width. How thick or what thickness of the line that you want. So that thing you can also change by using LW. So that you can use by using LW will stand for line width, and you have to play around with this numbers a little bit. There is no such measures of these things, so you have to play around and see what thickness that gives you the best visualization for you. So also one thing is that the legend location, we were being giving the lower right location. That's why it was giving the lower right. But at the same time, you can also give it, but it could be the best. You just provide a location equal to best. So you do plt.legend and then within bracket you do location equal to best. So if you do that, what happens is that, depending on your data, depending on the size of the data that you have, wherever it finds, there is space, if all the legends can be fit properly, it will do that. So, it is as advisable that you use location equal to best in the legend. So plt.legend, location equal to best, then you do plt.show. That's something that, legend location could be good. Okay, next is your xlim and ylim. So what does your xlim and ylim means is that it means that your x limits and your x limits and y limits basically. So if you have want to start from somewhere and want to stop somewhere, or what you can do is that basically you can do this one plt.xlim and then give your x limit you want to have 0 to 7 and plt.y limit, you can give that y limit as well. So these would be your how you can set your x limits and y limits. Spline like this you can see all the diagrams, all the this box, all the four uh, lines are there. If you want to make something invisible, say here I what I made is that the right spline I made it invisible. Okay, so I made the right spline invisible. So what you can do is that you can do an AX stands for your axis dot splines, and then you can set whichever right or left dot set visible false, and then you can set it over here. So you see, if I do the left, then left one goes out, and if I do my right over here, the right line goes out of the picture. Okay, so one thing that you see here, we are coming to this thing is called your subplot. So here, what we've been doing is that we've been just plotting only one graph. Okay, only one graph that we have been plotting over here. But what happens if we want to plot multiple graphs in the same, multiple charts in the same plot? How does it going to have? Yeah. So what I was trying to do is all over here. So this was top. So top, and I think it was the bottom of this top. Yeah. So the up is not the upper, is actually the top. If you do top, then the upper spline would become invisible. So depending on top, bottom, right, left, whichever spline you want to make invisible, you can do this over using this one. Okay, so let's talk about the subplot first, and then we can talk about different types of plotting that you can do, like your scatter plots and all. So and there is a difference between subplot and subplots that we have to keep in mind. So here, look at this problem. Here is that create 4 subplots. I want to plot 4 subplots. Here, first one would be your y1 equal to x. Second one is y2 equal to x squared. Third one is y3 equal to x cubed. Fourth one, y4 equals to x to the power 4. So these are the 4 charts that we want to plot. And it says that use 10 points between x equal to 0 to x equal to 10. So use 10 points between 0 to 10. And and also it tells you about that the first subplot should be in red circle, second one in green, third one in blue triangle, and the fourth one in black squares. And you have to give your each subplot a title as well. So here what we'll have to do is that first, input numpy as np, and then first we'll basically have to create x. So we first have to create, this vector of the line. So as you have seen that we can create it many ways. So one of the way we can use np.linspace. So we are just using x equal to np.linspace 0, 10, 10. So between 0 to 10, and it will have 10 points in between. So this is my first thing got over. That is my, what was the first thing? That was my creating of x that got over. Now what we have to do is that we have to create y2, y1, y2, y3, y4. These four variables that we need to create. So we need to create y1 equal to x, y2 equal to x square, y3 equal to x to the power cube, and y4 was y4 was not x to the power 4, it was square root of x. So here I'm doing it np dot square root of x. Now what I have to do is that now I have to tell how many plots that I'm going to do. Okay, so how many plots I'm going to do here? I'm going to do 2 by 2. That means that there will be a total of 4, and they will be divided into 2 by 2 4 plots will be there. So in the subplot, first would be how many plots you want, and after rows. In the row there will be 2 plots. In the column there will be 2 plots. So 2, 2, and then the comma tells you which plot I am now going to do. So it will be total number 2, 2, and then first one would be 1. So first one, what I'm trying to plot, first one I'm just trying to plot your y1 equal to x. So this is the first one I'm trying to plot. So what that will be, I will write plt dot plot, and then within comma, first argument would be my x, comma y, and then, and I have to provide the specification regarding the type of line it is going to be. I want to use subplot, not subplot. So what it will do is that first you need to provide something like the figure f and comma. You need to provide the axis information. That you can say f comma x anything. And then here what you have to do is that plt dot subplots. Here is subplots. Here subplots you just provide to how many rows would be there and how many columns would be there. So here I want 2 by 2. So I want 2 rows and 2 columns. So plt dot. So just keep in mind the difference, the nuance difference in the syntax between subplot and subplots. In subplot, there it accepts 3 arguments: 2, number of rows, number of columns, comma, which plot I'm doing currently. But here, plt dot subplots, here you give the number of rows and number of columns. And then what you do is that you give like the axis information. In this axis information, you give 0, 0. That means that 0, 0, that is the first plot. That is my, first row, first column, 0, 0, 0. And then, so what I'm trying to say is that the plot that you are doing in subplots, if you're using subplots, that is controlled by the axis information. So, I have given it ARR, you can give any name. So that's your axis information. So that after that, you have to do axis information. There you have to say 0, 0 would be your first row, first column. 0, 1 would be your first row, second column. 0, 1, that's this one. So this would be your axis information. 0, 0, 0, 1. The that means the first row, first column. First row, second column. This is your 1, 0. That means second column, second row, first column, and 1, 1 means your second row, second column. So just see this subtle difference between subplot and subplot. So when you are doing subplot, it was just your number of rows, number of columns, and then whichever plot I'm right now doing, first, second, third, fourth. And the only difference is that with subplots, I'm giving an access information. First, I'm saying how many rows and how many columns I want. That is given by plt.subplots. And then with that access information, I'm giving it which plot I'm doing, 0, 0, 0, 1, 1, 0, 1, 1. So this is a very subtle difference, but you should know the difference between subplot and subplots. And you can use either of them, whichever you find is easy to do over here. And then, so you see here, you see here, the first, the figure which is in red versus the figure which is in blue. You see that these almost have got mashed together. Okay, so they almost have got mashed together. So how to adjust the spacing in between them, how to do the subplot spacing adjustment. So these adjustments, subplot spacing adjustment can also be done. That subplot adjustment that we will do. So the command that does the adjustment is called your plt dot subplots underscore adjust. So plt dot subplots underscore adjust, that does this adjustment, and then you need to give whatever your bottom, left, right, top, and horizontal spaces are there. So now how to interpret all this? Now all of these are in the percent of the image height width. The margins are sort of like CSS style margins, only related to the bottom left corner. In other words, right 0.99 means that the right margin is 1% away from the right edge. So the top margin 0.90 means that it is 0.1%, 1.1% away from the right edge. The parameters H space and W space, they control the spacing between the subplots. These are kind of hard to get because obviously there are more. So it's a little bit difficult, what H space or W space you provide over here, because these numbers basically it will be difficult to interpret, but you have to just play around with it by changing these numbers. Maybe you have to do a few tweaks, you have to do a few iterations, but these are the ways you can get your line spacings between the subplots that are done. So yeah, so that's your subplots. The difference is there. So subplot and subplots, just keep in mind that there is some very small differences between subplots and subplots, how you are going to take care of that. That's how you will be doing. Okay, after that, let's see different type of plots that we wanted to do. So, for example, if we want to do a scatter plot, now everyone knows what is a scatter plot. Scatter plot looks like this. So, this is basically a scatter plot. So, you have your x values and you have your y values here, and you basically so that's a scatter plot will look like. And so we need to create some numbers first to generate this one, x and y. And yeah, so you need to if you want to find out if there is any correlation or any trend between the scatter plot, sometimes can give you a good indication that. So here I'm generating some numbers like x and y. That's or if you have data in Excel, you can also import it using pandas. After that, how you are going to run your scatter plot? You'll need to run your scatter plot as plt.scatter. So plt.scatter would be So PLT is the universal, every time will be there. But after that, for scatter, it is scatter. For histogram, it would be dot hist. So like this, you will have to do it. PLT.scatter, and then you give your X and Y, comma, color. Color a color of the line or color of this, and then you give s equal to 30. So what does your s equal to 30 means? S is the size of point in scatter plot, how many numbers you want to have it here. And then you have your usual plt.x level. You give your whatever name you want to give, just give any name, and plt.y level. Then you give plt.title, and then finally you do your plt.show. So this is how you are going to handle a scatter plot, which is very, very easy, scatter plot. Now, there would be a histogram. Now, can you guys tell me when we use a histogram or what does it say? So, histogram basically shows you a frequency, that is the number, how many times in a data set it has appeared. So, the value versus how many times it has appeared in a data set, that is basically is done by histogram. So, we are just drawing some data over here, and after we have drawn this number, so basically what we are trying to do is that 1000 random number drawn from a Gaussian distribution. This is normal distribution or a bell curve data. Okay, so we are generating this data basically out of this normal distribution. So how we are defining this normal distribution? Normal distribution, as you know, we need to provide the mean and the standard deviation. So np dot random dot normal means that we are asking it to generate data from a normal distribution. The mean is 2, standard deviation is 3, and what does 1000 mean? 1000 means how many number of data points we are going to generate. So we are going to generate 1000 data points. Now after it has generated, so it means that it has given you 1000 data points. Now after this 1000 data points, you need to see which number has appeared how many times. So to see that, what we need to do is that we need to do a histogram. And what is the function for or syntax for writing a histogram is plt.hist. plt.hist, H-I-S-T is the histogram. plt.hist, then within bracket you give the name which is called data, the name of the data series which is data. And then obviously you will have to add an x level, you have to add a y level. So plt.x level you give the name of the x level, that is value. plt.y level you give frequency, plt.title, whatever title you need to do. And finally you have to have plt.show. If you do not have plt.show, your graph will not show over there. So this is how you do a histogram, and this is plt.scatter. You do a scatter plot. So and now so if you just get this, it's not going to do it's just not going to do it on its default whatever it finds the data, it does it. But if you want to have more control over it, so that this represents the 1000 data points in 10 beans. So 10 beans, one bean means that the interval that you are looking for. So for example, you're looking for, if you have data set in that, the age is between 10 to 50 years, and then, your data, so your age is in discrete numbers. So, so for example, say, I'm just explaining you what does your bean means. Okay, I'm not trying to here, age. So here you see the customer age. Customer age is because customer age. So this is basically a data on credit card holders data. So we're just trying to figure out if the person is going to default on the loan or not. And we have collected data on numerous things. So customer age would be a discrete number. So it would be like 1000 customer. I will have each of their numbers, and in this data set, the minimum age was found to be some 23, and maximum age was like some 60 years of age. Now you cannot when you do your regression modeling, you cannot throw the data in this way. So what we do is that something we create bean. Now what is a bean? We will have the minimum 20 to maybe 30. The next bean would be my 31 to 40. Then would be 41 to 50. So like this, we create slabs of the edges. So that's what the bean means. And so, so that's what it has created 10 beans from minus 7.5 to some number, some number, some number. So 10 beans. It has created on its own. But, the data does not look good. And maybe if you think that we can do a little better. So you can also give that beans information here. So in this hist. Rather, I can give this data beans 20, whatever terms it can give we can give it here. So so whatever number of beans you want to have, you can provide it here. And then figure subplots adjustment you can do by using the W space and H space and the distance from the margin by left, right, top, bottom, etc. And then you can do your plt dot show. That will do will show the graph. So we now have done histogram, we have done a scatter plot. Now let's see how we can do a bar chart and a simple pie. So bar chart, this is like your bar chart. Okay, so you see that what does the bar chart shows you, each of these three, what are the bar height and the numbers. So for how you will be showing this bar chart, so the bar chart would be shown by dot bar. So you will have plt dot bar, that dot bar, it will do that, it will do the bar chart over here. So in this, you provide your values over here, and these values it is going to show you. Let's now go over to the pie chart. Stack plots, if you want to do stack plots. So stack plots, it will be different days, 1, 2, 3, 4, 5, how many days, how many hours of sleeping, eating, working, playing, all these things are happening over here. So you can do this by stack plot. So to do that stack plot, you will have your plt.stack plot. And then you provide the data sets over here and then provide the colors as well. So this will have your stack plots over, it will give you the stack plots. So you can see that the R, here we can see, at least in colors, how we are spending our data. The problem is we don't really know which color is which without looking at these things. And so you need to add some legend. You can add some legend as well using level of these colors. Now next comes your pie chart. So possibly if you want to see that in each of these days how many hours you are spending on different type of activities, it is possibly better to see in using a pie chart. And in this pie chart, you give the activities: sleeping, eating, working, playing, etc. And then you do how you will be taking care of the pie chart. Pie chart would be your plt.pie. If you want to add axis, you can do add axis. That would be your figure dot, anything you did dot add underscore axis. So within this you need to provide what are your y mean, x mean, and what would be the increments over here. Do your add axis, add underscore axis, that will do. You can also add two axes as well. That is also possible. Two axes you can do that. And workflow in Matplotlib. So Matplotlib, how you are going to go ahead with all this plotting. First one, what you have to do is that you have to prepare your data. That is, you have to do what data you are going to plot. If there is scale difference, just create, you might have to change your data, pre-process your data. Second, you have to do the create the plot, and then do the plot customization. Then would be your save plot, and then show the plot. So it's also important that if you want to save it in any particular format, like any .png or anything, you can have it like plt.savefig, plt.savefig, and then you'll get foo.png. So what it will happen is that this will get saved as that format that you have specified in your working directory. So in your working directory, it will get saved. So it's also very important. And finally, it will be your plt.show. Plt.show will be your final thing to do that, to show it, plt.show. So you can also have different types of plot. If there's something called contour plot to show the contours of your data set, you can have using contour, plt.contour. You can have vectors to show the arrays of the thing. You can have vectors, so that would be your plt.gca vector plot, violin plot. There are many types, but I have covered whatever are your whatever your the main figures are there. So saving your plot, you have to do plot plt.savefig, and then give it whatever is there. And then finally, what you have to do is that you have to close and clear. So finally, it is better to have clear an entire figure plot.clf, or you want to close the window, you can do plt.close. So plt.close would be your, after you have done plt.show, after that you will be there. It will just finishing up of the entire thing. So whenever you are doing a 3D, you just need to do that. You need to tell Python that, see, I'm doing a 3D plot, projection equal to 3D. That and these are the comments that you can use for if you are trying to do a line plot, 3D line plot by using line, or wireframe surface if you want to do this kind of a surface, or a contour plot, or polygon, bar chart, 3D bar chart. Very much the way we have done. Only difference is that in all of these you have to write a new set of parameter, that is projection equal to 3D. Projection equal to 3D, and this is your quiver line. The same way, all the things that we have done, that those can also be done in 3D plot, just using another line, that is your projection equal to 3D.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.